Hey, welcome back to MSP Helps with Precal. This is Unit 1, Topic 4, Lesson 1, and we are going to be multiplying and dividing rational functions. So we're going to start off with a warm-up with multiplying and dividing fractions before we get to the rational functions. So when you did this, you probably multiplied numerator times numerator and denominator times denominator, but you also found that there were tricks. You could reduce it vertically or you could reduce it diagonally. Like for instance, 5 and 10 both have a common factor. They can both be divided by 5. This divided by 5 is 1. This divided by 5 is 2. 3 and 12 can both be divided by 3. That divided by 3 is 1. This divided by 3 is 4. Then when you multiply, 1 times 1 is 1, and 4 times 2 is 8. Now, I'll show you that would have given you the exact same answer the other way around. So 5 times 3 would have been 15. And then 12 times 10 is 120. And then both these numbers can both be divided by 15. 15 divided by 15 is 1, and 120 divided by 15 is 8. It's going to give you the same result in the end, but it's just easier when you have smaller numbers to begin with. All right, so 4 and 8 can be divided by 4. 9 and 15 can be divided by 3. And then you've got 5/6 as your answer. Now, dividing is very similar. You're going to do a process which I like to call leave, change, change. I'm going to leave the first fraction alone. I'm going to change from division to multiplication. And I'm going to change 6/20 by flipping it. So I'm going to flip it to its reciprocal, which is 20 over 6. Then I can start reducing. 4 and 20 can both be divided by 4, and 3 and 6 can both be divided by 3. And then I multiply across. 1 times 5 is 5, 1 times 2 is 2, and 5/2 is your answer. All right, same thing for this one. I'm going to leave, change to multiplication, change to the reciprocal. Then these two numbers can both be divided by 9, and 1 times 2 is 2, and 1 times 5 is 5. Remember, you can also reduce vertically. It just didn't happen in any of these questions. You can reduce vertically or diagonally when it comes to multiplication. When multiplying fractions, you can cancel diagonally and vertically, as I just said. And when dividing fractions, you got to use the process of leave, change, change. All right, so before we are canceling, so this is basically the same thing we had already done when we did graphing. So we're going to first factor our polynomials as much as possible. So the top is going to be x minus 6 times x plus 2, because remember, these are the only two factors that these are the only two numbers that have a product of negative 12, but also add up to negative 4. And then on the bottom, this is differences of squares. This is x plus 2 times x minus 2. And then what you notice is that just like we just did with the warm-up, that we end up having the same factors on top and bottom. So x plus 2, those basically turn into 1s. And that leaves you with your answer, which is x minus 6 over x minus 2. This question here, okay, so we're going to factor the top. So that's a perfect... So factors this makes x minus 6 times x plus 3. Keep in mind, you can flip these two around, but you can't switch the symbols. According to commutative property of multiplication, you can switch the way that they're written, but if you switch the symbols, then they would add up to positive 3 and not negative 3, so you can't do that. Down here at the bottom, it's x minus 6 times x plus 6. The minus 6 cancels out because you have the same factor on top and bottom. Those basically just turns into 1s. Anything divided by itself is 1. And then you're left with x plus 3 over x plus 6. Okay, so multiplication questions. So a couple more. So now what if we have a rational times another rational piece? So you're going to do basically the exact same steps. So you're going to first factor it as much as you possibly can to begin with. So this is a perfect square of x minus 5 times x plus 2, negative 5 times 2, and negative 5 plus 2. And this is down here is going to turn into x minus 5 times x minus 1. Multiply them, you get positive 5. Add them, you get negative 6. And then multiplied by. Now keep in mind, I'm not going to use an x here because I think that will get a little bit confusing. I know you normally use x's to denote multiplication. X minus 1 is already in simplest terms, and at the bottom this is differences of squares, so that's x minus 2 times x plus 2. All right, so now I can do the same process I did before. I can reduce diagonally and vertically. I notice that we have common factors diagonally here of x plus 2. X minus 1s cancel out, so this basically turns into a 1. Now I say that because you need that as a placeholder in the numerator. If it was in the denominator, anything over 1 is itself. But when it comes to the numerator, you need that that placeholder. And then x minus 5s cancel out, so basically this all turns into 1 as well. 1 times 1 is 1 on top, and 1 times x minus 2 is x minus 2, and there's your answer. All right, so one more. Now 5x, I'm going to do the silly thing, and I'm going to take that one term and I'm going to split up into two factors, and you'll see why later. 3x minus 12 have a common factor of 3, which leaves me with x minus 4. This is here. 3 times negative 4 is negative 12. It's the same thing. I just factored out the 3 and multiplied it by, not sure why I put equaled. All right, guess I'm going to have to erase. All right, there we go. So multiplied by, and over here we have x minus 4 times x minus 2. And on bottom, we have an x that can be factored out. So both these terms have an x, so that leaves us with x minus 2 on bottom. All right, so x minus 2's common factors. We have x minus 4 common factors diagonally. And then we also have x and x right here. So remember, I took out that as a factor. And I'm left with, so this is all 1 and this is all 1. 5 times 1 is 5, and 3 times 1 is 3. So believe it or not, this actually comes out to an actual number of 5/3, 1 and 2/3, 1.6 repeated. Okay, so that takes us to the end of multiplication. Now, division is not going to be a whole lot different. It's going to be the same first step as we did on the warm-up. So I'm going to factor just as like I did before. So this is x minus 1 times x plus 1. Differences of squares. And then 3x minus 3 can be factored out the 3, which is this. Now, leave, change, change. I'm going to change this to a multiplication problem. I'm going to change what used to be on the bottom, now put it to the top, and take the top and put it to the bottom. All right, so now I look to see. Cross simplify. Doesn't look like I can do anything else, so it looks like we have 8 times x plus 1 over 3 times x minus 1, and that's as simplified as you're going to be able to get in this case. Now, you could distribute these numbers back, or what you could also do is you could divide 8 divided by 3 and leave that number on top. That is another way of simplifying as well. All right, so the next one, I'm going to do x. So I'm looking for, what's that, negative 11 and x plus 2. And then on bottom, we have x 24, so it's not going to be 12 and 2, 8 and 3. So it's x plus 8 and x minus 3 being multiplied by. Now, once again, I'm going to flip this, leave, change, change, put the x minus 3 on top and the x plus 2 on bottom. Now I'm going to look to see if I can simplify by reducing diagonally, which I can. I can also reduce diagonally here. This turns into 1, so does the bottom. And it looks like I'm left with my answer, which is x minus 11 over x plus 8. All right, last example for dividing. This time we actually have multiple things going on here. So we have 3 different rationals being multiplied or divided by each other. So x over x plus 5 cannot be simplified anymore. Okay, whatever, multiplied by. So this is going to be 3x minus 5 over 1. I'm just going to give myself a placeholder here because anything over 1 is itself. And so this is going to be leave, change, change. So I'm going to take what was on the bottom, which is x plus 5, move it to the top. And then this is factorable. This is actually differences of squares. This is 3x minus 5 times 3x plus 5. Because 3x times 3x is 9x squared. 5 times negative 5 is negative 25. And the outers and inners of FOIL are going to cancel each other out. So they're going to be positive 15x and negative 15x. That's going to cancel out. Now I'm ready to reduce diagonally. So this factor and this factor can cancel out. Even this factor and this factor, which it doesn't matter that it's 2 rationals away from each other. they can still be canceled if they're diagonal to each other. The x doesn't have anything I can cross it off with, and the 3x plus 5 doesn't have anything else either. So it looks like we have x times 1 is just x on top, and 1 times 1 times 3x plus 5 is 3x plus 5. And we're done. Now you might be wondering at this point, I've had this question before, why can't I reduce the x's here? Because this is not, x is not a factor here. This is actually all one. So this is a binomial right here. So this is linked with addition process. So it would have to be x times something. So it has to be a product. It has to be multiplication in order to reduce diagonally, because that's the rules for multiplication, not necessarily for addition. So you can't just say x over x and cross them out. That doesn't work because x is not one of the factors of the 5 also. So we have two different terms here. So that is a difference. All right, thanks again for watching. I'm going to stop right here, and I'll make the next video here momentarily. And thankfully the pen is working again. I know in the last set of videos I made, it wasn't working very well. All right, thanks again for watching. Have a great day.